Okay, this is an older Manitowoc ice machine. Got a little problem with it this morning, and what's happening on this machine is it's making ice really nice. Ice, but it's not dropping it. So I have to check the vanes on down there where they're soldered on to see if it's broken. That happens. It separates. The other thing I have to check is that cross solenoid valve. The other possibility I'm having would be if my head pressure is insufficient for defrost. There's something interesting. We look all the way back there. See, that's the suction line. See the frost on the suction line going into the compressor? That tells me that that's how I've always checked these old ice machines to tell if it had a proper charge or had enough refrigerant in the system. Is if it's frosting back to the compressor. You don't want frost on the compressor, you just want it right on that pipe. And that means that the evaporator plate down here, let me see if I can. That tells me that the evaporator plate it's getting liquid refrigerant evenly across the plate. But what's happening on this machine is the ice builds up, gets thick enough, and it makes contact with the switch here. There's a small voltage current, and when the ice builds up, the water touches the metal prongs here and completes the circuit. This goes back to the circuit board, and the system goes into its defrost cycle. It's a low voltage connection. In the early days of this machine, they had a problem with the water had too much salt in it, like in Florida or South Carolina, Georgia. You had a solution. It was like a battery, actually. You were actually making a low voltage, and it would keep it into its ice making mode. It wouldn't let it go into its defrost mode. Okay, this machine's. We look at the serial number on this machine. It's a 1994, and that was when they were converting over from refrigerant 502 to, they weren't sure what they were going to put in it. So what they ended up doing was they ended up using HP81. And they only did that for like 1 year. Then they switched over to 404. But This system is an HP81. It's very rare. We run into a couple of them. They used to sell HP81 in little green bottles. I bought one bottle and I've had it. I used it one time and I've had it since then. Now it's, I don't know if you can even get it. It's probably very high priced. What I've done is I converted this over to 407F. Let me see if we can get the light on it there. 407F I put in it. Works very good for this because it's more of a R22 range and not the 404 range. If this had a 502 expansion valve in it, I would have put 404 in it. But because of the lower head pressure range, the 407S was a very good match. And you have to add some POE oil to the system. But what I'm going to do is I'm going to let it make a batch of ice, and then I'm going to reclaim it, the refrigerant out of it. And my guess is the problem is in this valve here, the solenoid valve, that it's restricting the flow of refrigerant through it. We're not getting enough gas going through the evaporator coil when it goes into its defrost cycle. The system's got some miles on it. But what happens is the defrost solenoid valve is connected to the high side, the hot gas discharge. And when it goes into its defrost cycle, the solenoid valve opens up and lets the hot gas, instead of going through the condenser, it goes down this tube to right after, just past the expansion valve. That's the expansion valve. And it goes just after the expansion valve. It's a hot gas defrost system. And then from here it goes through the evaporator coil, out of the evaporator coil, and back through the compressor. So you get a momentary hot flash going through it, and then it gets kind of cool. But it's the trick is to move enough refrigerant through it to defrost the ice. Now I did run ice machine cleaner through it. That will solve that problem usually. What happens is this, you can see right here this calcium, and it's from the water. It's in your drinking water. It's normal. It's good. It just looks pretty dirty, but it's not. It's just calcium is all it is. And what that calcium does is it sticks to the metal evaporator plate, which is a bunch of little cube holes, and it's nickel plated, and that calcium acts like sandpaper. It gives the ice a foothold to hang on to. So when it goes into its defrost cycles and the plate warms up, the ice has that foothold, like sandpaper-like foothold, to stay there, and the ice will just stay in place. Instead of dropping out, it'll just stay in place and melt in place. Then the machine will cycle off if it doesn't go into harvest yet. It'll do that a couple of times. This is the circuit board for it. This machine's, what is it, 20 years old, 94. It's difficult to get parts for this old machine. But it was a good machine when it, back in the day. A good standard machine. Okay, you can see this red dot here is the contact that the ice is making with the probe. It's right there. And the machine just went into its defrost cycle. And we can see I have 143 pounds head pressure. 146 pounds head pressure. And what it's doing now is valve is open and letting gas run through it, and it's not very hot. It feels cold actually. It feels warmer on this side than it does this side. And I think this is restricting is what's happening. Just not opening all the way. And we'll see the ice will start moving out and then just stop. See, the ice should have fallen out by now. And you can just, it's just barely moving. The circuit board will time this out. It'll allow it to go back into its refrigeration cycle a couple times and then just shut this machine down. See, it's starting to move a little bit. I don't know if you can see that on the camera very well. But I'm getting a little bit of movement on it. But the weight of the whole slab of ice should have dropped by now. And you can see that the thickness controls on an angle, and it's out in the air right now. The machine just came off its defrost cycle and it went back into the refrigeration mode, and the ice didn't fall down. You see it's making ice again. That's our problem right there. Okay, so now I'm going to reclaim the refrigerant out of the system and change the valve. Okay, I'm taking the gas to my gauges with the yellow hose into the reclaimer, out of the reclaimer into the tank. I use this reclaimer for small systems like this. It just pulls the gas out fast. It's pretty okay for little systems, and it's convenient because it's lightweight. I think it's the CPS is what it is, the brand. It's okay. For bigger systems, pumping liquid right now. Bigger systems I use a different one. This doesn't have a condenser on it. It's the only negative thing to it. But it pumps liquid pretty good. I'm taking the liquid out of the high side only. I got the suction closed off. Alright, in a couple minutes I'll be done with that. Okay, this is gotta take this old valve out. So I unplugged the machine so there's no power to it. But those are my connections right there. Get them out of the way. I don't like melted wires. Don't ever want to do that again. And this had this little snap-on device. This is just something to point out with solenoid valves. It's electric coil in here, and they do heat up. And if you don't put this cap on, or the little screw for sporlins, what happens sometimes, through operation and vibration, it'll ride up like this. And I found the coil cooked in that position because it overheated. Apparently the heat transfers into the metal and keeps it, comfortable, and it'll last a long time. But you always have to put these caps on, or the little screw on them. Don't leave them off. That's kind of important. And this is the old style coil. Okay, now I have to take this out, and the dryer filter is just around the corner over there. It's kind of a little difficult to get at, but I have to do that also. So now I'm going to be using the torch to pull these out. I've got the line vented. I just have to open up the valve. Watch what's beyond the flame. There's electric wires and whatnot. Okay. Let's try to get that dryer out. Okay, that's the old valve, the old solenoid valve. I'll take it apart to see if it's just probably just went limp in there and just not working good. Hopefully that's the problem. It's a new valve. I put together. This is stainless steel with copper clad on it. I put liberal coat of cool gel on the body because these the old solenoids, you could take them apart. There are two parts when you want to braze. That way you just did the brass body. But this is a little different, and I'm just a little concerned about if there's a nylon seat in there or whatever. I don't want to, you know, destroy it. But here's the Manitowoc. Came with some nice instructions. Let's see if I can zoom in on this. And what it says right here is, it says right here, 15% silver solder is recommended, although silver bearing solder in 5 to 55% can be used. So this stainless steel copper clad fitting, what I did was I cleaned it. I did put flux on it because I just like flux in it. I just have confidence in the surface adhesion. And I'm using, let me see if I can, and I'm using this bearing solder here. It's I believe it's 55% silver, and the beauty of it is you don't have to get the part so hot for it to melt. It melts at a lower temperature, and that's what I'm gonna do right now. Let's see, where can I put you guys? Okay, I'm gonna braise this up out here because it's just easier to get at than in the machine. I want to make this connection and then I'll put it in the machine. This is the far away connection, and what's important is the arrow on the valve body. The arrow on the valve body is pointing this way. You have to be careful of that. Not too long ago I put a dryer filter in backwards, and a couple guys commented that they caught that. I had to go back, and it was a freezer I did at a sandwich shop. I did go back and change that or correct that. But yeah, the arrow goes this way. So now I want to braise this up with this silver bearing solder that melts at a lower temperature than other solders, other brazing rods. Using a smaller tip too. The instructions said usually I would start brazing over here, but the instructions said to do the copper first. You don't want to overdo it. It'll just flow in there and plug up the pipe. Well, that was quick and easy. Let's see, this is my wet rack here. I didn't use nitrogen on this, and I really didn't get any carbon built up in there. It's such a small connection, it's not worth dragging the nitrogen bottle all the way up here. It's good practice and all that, sure, but it's just sometimes you just, if I was doing a lot of brazing on this, I would do that. I would get the big elbows or something like that. But you can see the braze, it came out pretty okay. I'm happy with it. Okay, now I'll put this in the machine. Okay, I got the valve installed, and the arrow's pointing away from the compressor and the condenser toward the expansion valve down here. That's where it feeds in. And I changed the dryer filter. You can see it back here. My Appion hoses, I had to hook up. Luckily, this dryer filter was the only one I had, and it had two fittings on it before and after. I had to hook up my Appion hoses there because they wouldn't tighten on the Manitowoc fittings over there. I tightened them down, and the hoses were loose. It just wasn't seating. Must be the way the hose is the nipple is designed. So luckily, rather than having to install some straighters, I was able to use those parts. And we're pulling into a vacuum. I'm gonna get there in a little bit. Now I wanted to put this, button this stuff up. It just snaps on. That's pretty good. New device. They eliminated the cap. To get this off, you have to put a screwdriver in underneath it, and which is a little difficult. You had to get a little sharp screwdriver to get in there and give it a tap, and it popped the head up. Actually, I put a big flat head screwdriver in and twisted it sideways over here, and that popped it up. But it's that's good. That way people won't leave the cap off. You just have to make sure it's on all the way. And these slide-on clips, they look pretty okay. They have to do the job. 115 volts. It should be. Let me check the voltage on this new. Some of the machines. Okay, it does say 110, 120 volts on it. It's let's see if we can see it. This focuses in. Anyhow, it says 110, 120 volts on it. There we are. Okay, I gotta secure this to here, and I'll finish the vacuum. Okay, I got a pretty okay vacuum. I don't know if you can see that. I'm gonna stay with that. Here's something I wanted to point out. My ball valves here, I opened them up momentarily earlier, about an hour ago, and let me see, got my 550s into a vacuum, and it held really good. It stayed right on the money right there. And they haven't changed. This is a newer 550. I was a little concerned about them holding a vacuum because there's O-rings behind these knobs. I've had those leak in very cold weather. Had liquid refrigerant coming out of them. But what they changed this year is these fittings were swivel with O-rings in them, and they made them solid, and so they don't swivel anymore, and it seems to have worked. I don't know if this would get into a very deep vacuum, a low micron, but it